Hi everyone and welcome back. First, want to thank you for two things in particular. One is to do work all along the week. You have not waited like at the last minute to publish your post. And second, which follows the first actually, is that you have commented each other's work really great. So that was really interesting to read all of your discussions. So I encourage you to continue like that. You went beyond the expectations and that was really great. Now, before going to Module 2, I just want to show you one thing on the Program Resource Center on my IB. Of course, you have the middle years program, and I don't remember if I have shown that to you last week. Among the cross-program resources, there is the document What is an IB Education, and if you access it, what you'll have is here. It talks about, it's like a short document, not many pages, that just summarizes key elements of the IB program, among which, of course, international mindedness and the IB learner profile, which goes with the IB mission statement. And then it talks about the curriculum, the approaches to teaching and learning, and basically sometimes people ask us, like, what's the difference between like being in the IB program or not being in the IB program? And often it all comes to this summary actually. So this is something that you might want. Among the approaches to teaching, I just take a look at it with you. There are 6 approaches to teaching that I always recall to my teachers actually as a MYP coordinator. It's easy, of course, it is based on inquiry. We'll see that later. Well, later, but not later. I mean, we will, in Module 2, develop a statement of inquiry. So this follows that approach to teaching. Also, it's focused on conceptual understanding. So you'll see that in Module 2, you will select concepts, key concept, and related concepts of mathematics in order to formulate your statement of inquiry. It's developed in local and global context. So you will have to choose a global context exploration in Module 2. And for the rest, we'll see it later in the action section of the unit plan. So to plan these, you see here the laboratory, to plan like how you will implement the MYP program in your class, you will have to use the unit planner. I'm gonna show you my version here. But it looks like that. I just added color actually to what the IB has done, and there's two models, one of which is I added also comments. I'll show it to you like later during the workshop. But basically here the learning process, it has to be like 4 columns. This is the way we are doing that since 2 years. So I'll go through it. This is an example I've done for another workshop. So I'll look into it with you during this video as well. Of course, at least the beginning for this week. So going back to the online workshop. So this is like the foundations of the MYP, building your MYP unit. So I've just shown you what looks like, what a unit plan might look like, and we'll start building it. We do not need the document at that point. We will just post every part of it, and eventually we will copy paste everything into our own unit plan. So during the next 3 modules, we will go through many parts of the unit plan actually to see how we can implement the program in mathematics. But it has to be something that will have an effect into class for the students, of course, because it's a student-centered program. So in Module 2, I've actually done an example, very short. You see, it took me not much time to publish like just an example of each of the 5 tasks here. So you might take some time to reflect, but you see that it's going to go certainly faster than the first week. So the activator actually is just to find a visual that can exemplify a topic, a concept, a skill, or more than one. There has been already many replies since you really prompt into it. So for me, actually, you've done all of that while I was sleeping, actually. So here, if I click on it, I've just added an example. Okay, so I ask you what is expected, and then I add an example. So there is no wrong answer, actually. Then for the learning, of course, there are the module notes to guide you through the modules, and then the learning engagement activity 2. We choose concepts. I refer you to the mathematics guide, page 22 to 30. What you'll see, if once again, if you click on my post, is that I have attached the guide, which has like a little minor update in May. And then you'll have to choose a topic, a key concept, two related concepts, and then merge them to form conceptual understandings. Of course, the module notes will help you to have examples of that, of what it's meant. It's well done. It has been refreshed, the module notes, so you can, of course, look into it, and then you reply by just posting everything. So I've done an example here. Basically, the conceptual understanding is like one sentence which shows something that the student is supposed to learn, and that will be able to be to transfer in other topics and other subjects. For instance, the validity of relationships can be proven using equivalence, can be used in year 1, 2, 3, 4, and 5, and could be used in science, could be used in economy, in other subjects. So this is the idea. It's something that the students will learn and that will be able to use like a skill, actually, because the students learn to, let's say, equivalence can be used to validate relationships. They learn that they can use equivalence to validate relationships. They learn that, and they will be able to use that skill later on. So that's the idea. There are many examples possible, and the concepts are on page, actually, I'll show you too. The key concepts here, there are 16 key concepts in the MYP. For all subjects, there are 3 which will be mandatory at some point between year 1 and year 5, which is form, relationships, and logic. They have been defined here on page 18. Then there are 12 related concepts in mathematics. All of these concepts have to be studied, like used, at least once during the MYP. So for, let's say, year 2, you don't have to select all 12 related concepts. But if I take a look at the mathematics overview of year 1 through 5, I would see all 12 related concepts. These concepts are defined on page, I've shown it to you, 53. So if I would go on page 53, I would see the definition, like what could be meant for each related concept. And you'll see that we can combine these to form conceptual understanding. So basically, of course, like just one doesn't mean a skill, but if you combine a few concepts, you will realize that it will represent a skill that the students have to develop in mathematics, and that can be transferred. So that's actually something that we can even do in teams. You can come up in a, let's say, a department, mathematics department, and just select concepts and build conceptual understanding. And it's nice to see that when you do so, perhaps many teachers from many years could use the same conceptual understanding. For the topics in the MIT guide, it's page 22 to 30. What I can say really fast is that there are 4, the mathematics framework has 4 branches. Here, if there are 2 scenarios. One is if you are doing the e-assessment, and the other scenario is that you are not doing the e-assessment. If you are not doing the e-assessment in MYP 5, then schools are not expected to address all branch in every year. So you don't have to do all 4 every year. It's not required. But you are not also, you are not required to teach every topic or skill suggested in the framework. However, if you are doing the MYPE assessment, then you will have to see all of the topics that have been selected for these exams. So there are two exams. There is a standard exam and the extended mathematics exam. So all of the topics and scale from MYP 1 to 3 has to be seen if you're doing the e-assessment. If you are doing the standard mathematics exam, then you add that column. And then if you are doing the extended, you add also the last one, the last column. The enrichment at the bottom is not covered in any exam, and you have that for all 4 branches. Then, if I go to the statement of inquiry, basically is the conceptual understanding put in context. So there are 6 global contexts that you'll see in the MYP from pages 58 to 62 of From Principles into Practice. It's here actually. So I have my 6 global contexts, and what you will see is that selecting one of the 6 global contexts, and then you will look at the example explorations and you will select one. For instance, let's say health and well-being would be one exploration. You don't have to choose all the dot. Just part of it is okay, and eventually you'll see that sometimes we can combine 2, as I will show you. Let's say I could look into the human impact of the environment of commercialization. So this is an example for globalization and sustainability. If I look into my example, I chose consumption actually, and European impact on the environment. And I had chosen relationship, quantity, and representation as concepts. And then my conceptual understanding could have been relationships between quantities can be represented. Of course, this is a skill that the students will have to do, how to represent relationships between quantities. And then I use that and I add my global context exploration to say that representing the relationships between quantities can allow us to evaluate the human impact of consumption on the environment. So you see that I have combined these 2 explorations with my conceptual understanding, and this would be my statement of inquiry. So this is what is expected. What you will see is that there is no mathematics involved. Of course, when I will get to my students, I could do representing, let's say, exponential relationships between quantities, or any other type of function actually. So for that part, you do not put the mathematics topics. You had selected it in order to try to think about something that you want to do, but in the statement of inquiry and in the conceptual understanding, you do not put the mathematics, because this sentence that you are using, another teacher from another subject could use exactly the same statement of inquiry, let's say in physics, in biology, and perhaps in economy, and then perhaps study the same statement of inquiry as you are. So that will foster possibilities for interdisciplinary units. So keep in mind that, of course, when you will talk about it to your students, you will certainly add the mathematics. So I have here, if you click on it, you see that I have added an example. Then going on, same thing, the GRASP forum. You see that we try to do an assessment task which is as authentic as it can be. There is a model that we can follow to do so. Once again, I have developed an example. Of course, we will talk later in Module 3 about the criteria. So for now, I'm leaving you explore it, Mario. And finally, in Learning Engagement 5, you will just have to state the relationship between your summative assessment task from Learning Engagement 4 and your statement of inquiry. Have a good week.